So without further ado, I want to take a moment to introduce Chris Salino, who is a certified LabVIEW architect and also a LabVIEW champion, and is the founder of gcentral.org. So I've been working with Chris for many years, dating back to his time at NI. He now works for DMC, which is not the DeLorean Motor Company, but used to stand for, I think, Jason, Dynamic Motion Control, right? That was the original. But it's one of our premier NI partners. They've got offices all across the United States. So they did some great work for Northrop Grumman, actually. And Chris will be talking more about that. Chris, let me go ahead and change over to your slide deck here. I'll let you have the floor. Thank you, Chris.
All right. I'm so excited about this presentation. It's a lot of fun for me to present to a group both locally and remotely. It is my hope that by the time this presentation is done, I accomplish 3 goals. I want to inspire you all. I want you to feel equipped to be able to do 7150.2. And then I want you to feel like there's some sort of a path or a road that you can traverse down to figure out how to do this. Before we do that, who am I? Travis, thank you for that very generous introduction. Like Travis said, my name is Chris Chilling. I've been around for, 20, 25 years in the industry. And like Travis said, I got the chance to start my career at National Instruments where I was there for 12 years. Did applications engineering. I cut my teeth and got my professional software engineering and software development skills in LabVIEW R&D, or actually DAC R&D for a good long while. And then I moved to marketing where I discovered that I really enjoy actually doing presentations, and for better or worse, I can actually talk a whole bunch. So my apologies. Speaking of talking a whole bunch, there's a lot that we're going to be presenting inside this presentation, so I'm going to try and go lightning fast. So after I left NI, I went to a company in downtown Austin called Cirrus Logic. Regardless of what phone you might have in your pocket right now, if you try and talk to your phone, you're talking to Cirrus Logic technology. That was really a lot of fun to be a part of that application. I was the LabVIEW framework architect, making the validation engineers successful. Decided to try a couple of things after that. One was starting gcentral.org, and that's still going on today. So I'm the founder, the president, and the treasurer for gcentral.org. And then I dipped my toe into this consulting thing with Compose Systems, great bunch of guys. Decided to do consulting kind of on my own, and then, joined forces with DMC about 4 years ago. Okay, that's a mouthful, so thank you for putting up with that. The reason why I present to you this background is because after 20 years of doing this, I have been able to distill the most motivating and energizing, purposeful statement that I can think of that drives everything I do. And I want to pass this along to you, use this statement as the canvas on which I'm going to paint the rest of this presentation. So brace yourself. It comes in the form of an I believe. I believe that as scientists and engineers, we get the chance to impact this world almost more than anybody else can or ever has throughout all of human history. This list of accomplishments, SLS, you take construction, AI, lots of different innovations, that's us in the room. That is incredibly meaningful and incredibly purposeful. One of the downsides to engineering is oftentimes we'll get mired in a whole bunch of details, and it's easy to lose track of this. When you lose track of the people whose lives you get to touch, engineering can become a drag. So I want to keep in front of us always, we get the chance to influence people's lives, and not just locally, but across the whole world, and not just today, but for years to come. Like we are currently standing on the shoulders of the engineers and scientists who came before us. We're in an air-conditioned room, sitting on chairs, eating food from a supply chain that was enabled by scientists and engineering. This is insanely purposeful work. And the only thing better than a scientist or engineer causing change throughout the world is when we get the chance to do it together, because this world is so amazing. It is so beautiful and so complex that there's no chance any one of us can decipher how everything works, bring our individual perspectives and passions to bear on that to do amazing things. We have to work together. We get to work together. And that's how we cause change in the world. And that is actually part of my story. My background, as Travis was mentioning, is very heavily software engineering, project managed, focused. certified LabVIEW architect, LabVIEW champion, lover of all things LabVIEW. I get the chance to bring that to bear at DMC, where I work with a whole entire team of folks where I can lend my experience and rely on their experience. So these are experts in test stand. We have certified test stand developers and architects. We have Veristand architects. DMC has been qualified as a National Instruments Center of Excellence. And it's not just software. We do a whole ton of hardware stuff as well. NI has recognized us as a silver partner for Vision, a silver partner for SystemLink, a silver partner as a system integrator. There's a lot of different things that we can do. By the way, you're going to see QR codes in the lower right-hand corner and then URLs that have links to all of this stuff. Also, Jason, I don't know if we're able to bring those printouts. So we've got printouts with a glossary of all of these links on. So if you don't catch them on your phone, no big deal. Okay, so that whole entire set of people and those applications, even though the NI toolchain is so powerful, the applications that DMC can solve are even bigger than just what the test and measurement organization, which is largely what uses the NI toolchain, can do. DMC has actually identified 4 different areas that we can service the world. The test and measurement group, that's the one that I'm a part of, we specialize in the NI toolchain, things like LabVIEW, so that we can make automated test stands, electric vehicle battery test systems, which we got to actually demo at NI Connect 2024 on the demo floor. There's a link to it. We do real-time and FPGA and vision and all kinds of other stuff. And so while we certainly are, I would say, masters of the NI toolchain, what's cool is we do other things besides NI as well, because NI plays together very nicely in a larger ecosystem. Like we can connect with Python. We can control other hardware. That's really powerful. Now, even though, like I said, test and measurement can do a lot, the types of applications and the customers that we get the chance to service oftentimes require additional specialties that are included inside of DMC. We have another service area called Manufacturing, Automation, and Intelligence. And my good friend Jason Mays is here. He's one of the directors at DMC. He's the head of the Houston office, and he works very closely with this group. So automation, think all things PLCs, HMI and SCADA programming, MES services, IoT solutions, robotics, etc. And test and measurement and automation have worked closely together to deliver end solutions to our clients. But we need more. Turns out we also have an entire organization, service area devoted to just embedded development and programming. They do things like firmware program, PCB design, low power system design, et cetera, et cetera. In fact, for the NASA BOLE project, the test and measurement team and the embedded team worked together to design printed circuit boards that we're actually shipping as a part of this end solution. So there again, we've got to work together to form solutions for these complex applications. The last team, general application development. That's lots of software languages across lots of platforms, spanning web, PC, cloud, mobile, UI, UX, you name it. And we've got certifications from Microsoft. Lastly, this is kind of like our secret weapon. Not only does DMC do software and hardware design and even hardware assembly, we have an entire in-house fabrication shop at our headquarters in Chicago. This lets us present a holistic solution from design to development to production to delivery, all under one roof. So that lets us control timelines and budgets and make sure that we're aligning with what clients need. This is really pretty cool. And DMC is distributed across the nation in 15 different cities. I'm based out of Austin. I get the chance to visit Houston. Jason's here in Houston. Like I said, I didn't get the chance to meet him. Come say hi. There's about 300 of us. And we all get to work together across different geographies, across lots of different application areas, aerospace, defense, government, chemicals, battery, vehicle, et cetera, et cetera. So earlier when I was talking about as scientists and engineers, we get to make an impact. I'm very thankful to be a part of this team impacting the world in at least these ways. That's meaningful. That gets me excited to get out of bed every morning. And what makes me even more excited is who we get to work with. You might recognize some of these companies, right? Some of these organizations. Now we're going to start honing in particular. So DMC is honored to have been selected by Northrop Grumman to work on the NASA SLS BOLE project. If you're not familiar with that, here's the case study. And you could imagine, in order for us to all work together, it turns out we have to share information and coordinate. And that's really, really, really hard. It gets harder with the more people that you bring into the overall solution. But we need to be working together because the world is too complex. It gets even harder when you're working across organizations and across geographies. NASA recognizes this. So much so, they put together a standard for software engineering to help people work together and coordinate. That's what 7150.2 is really all about. How do we put plans in place so that we all work together and are marching to the beat of the same drum? And it comes in 4 different chapters. So there's software management, software engineering of the life cycle, there's supporting the software during the different life cycles, and software documentation. Lots of we're going to talk about there. I like reframing those 4 different points in terms of the typical phases of how a project executes, more or less. So there's oftentimes the application that yields requirements, that generates designs, that's used to build the thing, and then we've actually got to use it. I like thinking about this in terms of applications answer why, requirements answer what, designs answer who, how, when, where, and overall cost. Then you got to build the thing and use it. And that might suggest a linear execution. And 7150.2 does not mandate a model of execution. This is a classic model of execution called the waterfall model. It has its strengths and its weaknesses. DMC has found it to be advantageous to have more of an agile approach. So that's more conversational with the client. We do some work, present it, get feedback, iterate on requirements, et cetera, et cetera. So this is how DMC executes, and we found it to be very, very beneficial. Again, 7150.2 does not mandate a model of execution. What it does mandate is that artifacts from each of these different phases is bidirectionally linked. So you have to link your applications to your requirements to your design to production, your production to you. Okay, here's the thesis statement I want to leave you all with. This is hard, but it's possible, okay? It's hard, but it's possible. And it's worth it because we have to work together. All right, so let's step through these very briefly. The application. Remember at the very beginning, I was showing a whole bunch of applications and how that's meaningful work. The application that DMC is working with Northrop Grumman on is the SLS. That's an incredible why. And I know I'm at NASA, but for everybody who's remotely involved, I want to just give a very, very quick summary. What is this SLS? This is the next generation of human spaceflight after shuttle. That's kind of a big deal. I was sharing with Travis beforehand. When I was a kid growing up, spaceflight was enthralling. It was absolutely captivating. I wanted to be an engineer, or an astronaut, excuse me. And then I went on my first roller coaster, and I discovered zero-G. Not happening, right? So next best thing, became an engineer, got to work on all this stuff. But this is very meaningful and purposeful work for lots of different reasons, lots and lots of different reasons. We zoom in a little bit. So SLS, part of it is the BOLE portion, Booster Obsolescence Life Extension. And so what this is about is retrofitting some of the boosters that were designed to go on shuttle, changing them so that they can work with the Space Launch System. Okay, so that's BOLE in a nutshell. We got to test those, right? So DMC is working with Northrop to create electrical production support equipment, EPSE, for the NASA SLS BOLE. So this is the NASA SLS BOLE EPSE. And I can throw lots of other acronyms in there as well if we need to for fun. You can imagine coordinating on all of this. It's really, really hard, but it's worth it. It's worth it. So that's the application in a nutshell. That's the why, and it's meaningful work. We can't lose track of that. Now we get into, my hat is off to Northrop Grumman and NASA for decomposing that SLS, the why, into very well-formed, very testable requirements. And here's our requirements language: shall, should, will, may. This is all mandated by 7150.2. Okay, DMC ingests those requirements and then we respond with plans, interfaces, and methodologies so that we can produce and develop according to particular ways and guarantee quality so that Northrop and NASA can use through acceptance testing, and then once acceptance testing is done, there's maintenance. So in a nutshell, that's what 7150.2 is aiming to do, to govern at each of those stages, more or less. Okay, great. What is 7150.2 again? It's about 140 engineering requirements, and there's a lot there. And not all 100 apply to everybody, depends on who you are. In fact, I want to say the first 10 or 20 are specific to NASA. So that's cool. And 7150.2 refers to, 10 or 20 additional other documents. So it's not just 7150.2 that we had to adhere to. It's a whole bunch of other things as well. Did I mention this is hard? Okay, but it's possible. And don't get mad at me. Building on the NI toolchain makes it harder, but it is still possible. Now, everybody out there in NI world, don't get mad at me, just hang tight, all right? Why do I say it's harder building on the NI toolchain? Because team-based workflows that use Git and the NI platform, like LabVIEW, TestStand, and VeriStand, yield these challenges. I'm not going to read through all of this, but in my 20-year career, this is what I have been challenged with and have developed systems to overcome. Things like when you have a merge or a pull request, commonly shared files, you're going to have conflicts. That's the LabVIEW project, LabVIEW classes, LabVIEW libraries. How do you merge files again? Forget about dirty dots. Graphical diff and merge, there are improvements. Thank you, NI, right? But it is still very challenging, very hard for a variety of different reasons. Code sharing is difficult. You either package your stuff up as a VI package or use NI Package Manager or use another technology like TPLs. Don't get me started on TPLs. Developer computer setup, it's complicated. How do you get all the right dependencies and all the packages installed so that you can even open up the source? In other programming languages, you don't necessarily need all of the different dependencies. It's just text. In LabVIEW, the code and the IDE are inseparably linked, which has its advantages and its disadvantages. Great. Build process hard. Code reviews require the code reviewer to have a fully set up machine. Okay. Automating software quality assurance requires significant tooling, continuous integration to UI testing, code, and worth it. Worth it. Because the nature of graphical programming, its inherent parallel execution and its ability to model how the world works far outweighs any other tool that I've ever seen. Not to mention the tight integration between LabVIEW and these other IDEs with a full, very capable hardware stack. And NI plays really well with other programming languages like Python and other hardware vendors like Tektronix and Pickering. So, worth it. Worth it. And as time goes on, it's going to get more worth it because at NI Connect 2024, NI presented Priority 2 and Priority 3 is solving that list of problems. So NI recognizes it as a problem. We've known about it for a good long while, working on it. Okay, now let's dive back into 7150.2. I recognize there's probably two kinds of audiences that I'm talking to right now. Either you're a developer where you're getting your hands dirty, or you're an architect, or you're a software project manager, or maybe you're both. Like I do both, okay? So I mentioned I wanted to equip everybody. So I'm trying to put tools and ideas at your disposal to make your lives better. We're going to start off with project manager. So for project and development tooling selection, you have a lot of tools that you can choose from. 7150.2 does not mandate any specific tools. That's for requirements, designs, or production. And you have to make some choices. All of these icons on the right-hand side is a whole cornucopia of tools that you can choose from. Whatever tools you choose, I strongly recommend, I would use the phrase mandate if I had that power, that you consider these three characteristics. Security, the tool that you choose better be designed to work together. So a platform-based approach of your software. And you need strong APIs. How am I doing on time? Okay. The reason why APIs are so important is because 7150.2 mandates a lot of accounting, linking, bookkeeping, keeping things up to date, and humans are terrible at that. They're terrible at it. Not only are we terrible at like detail management, we don't enjoy that kind of work. That's mind-numbing. I want to put somebody on the moon. I want to fly somebody to Mars. I don't want to keep track of which requirement hasn't been fulfilled manually. And, oh, there was a new release of software, now I have to re-audit? No. Computers are good for stuff like that. Whatever tools you choose, make sure that there is a robust API, okay? Jason, do you have those printouts by chance? So on these printouts, there's a couple of, the second page is the iconography. You're going to see in the upper left-hand corner. The first icon is for project managers, and the second icon is for requirements. So this is software engineering requirement 52 from 7150.2, and it says the project manager shall track and manage changes to the software requirements. Well, what's so hard about that, right? Big whoop-de-doo. Turns out there's a lot to that. Now, I'm about to overwhelm you with some graphics and some text, so bear with me. Okay. Can somebody say something to make sure that we are still connected online?
It's all good.
Still here.
All right. Great. Okay. So the project manager shall track and manage changes to the software requirements. No big whoop, right? Turns out the tooling that DMC selected and the processes that we put in place look like this. We chose Monday for our work management platform that enables traceability, work tracking, scheduling, bills of material, requirements, artifact tracking, et cetera, et cetera. As an alternative tool, there's also Atlassian's Jira. We also selected Atlassian's Confluence. This is where we track things like all of our knowledge, all of our decisions, which, by the way, 7150.2 mandates that you keep track of all of the decisions that were made. We use Confluence for that. All plans, documentation, and so much more. The graphic on the right are the different notions or tools that we created internally at DMC relying on Monday and Confluence. So just as an example, in the upper left-hand corner, we have this library of inputs because we care about what our clients need. So every document you give to us that is official and every version of that document, we enter into a library of inputs and we track it. Okay. So now I want to zoom in on one of these in particular. We'll take those library of inputs, that's what our clients told us, and we'll import it into a requirements traceability matrix using Monday.com. I want to show you a couple features of Monday, and again, you choose whatever tools you need, but they need to have this idea of traceability, et cetera, et cetera. So we take information from the library of inputs, and we create a row inside of Monday.com that looks like this, where the first element is just a summary, and then the second element, the requirement definition, is the exact agreed upon requirement text that we imported from a statement of work or whatever the source is, that we've tracked inside of the library of inputs. Something else that Monday gives us the chance to do is link items together. Those items could be requirements. We might generate work items like Scrum items to satisfy those requirements. We can link all those together. We might generate acceptance test plan tests that we link to requirements. Monday gives us that feature out of the box. Whatever tool you choose, you got to have that traceability and that linkability. But so much more. Monday also gives us a chance to declare metadata that serves us all throughout the project. Things like, what is the specific ID that we assign internally? DMC, I'm going to show you why that's important in just a second. Is this requirement safety critical? Because that means a thing. You've got to behave differently. Exactly what paragraph on what version of which document did that text come from? And did it change over time? Because remember, we have to manage requirements. We even assign both a client-side owner and a DMC-side owner and all that ownership entails for every requirement. We'll even track where'd that requirement come from. Is it a statement of work? Was it an email chain? Was it a conversation? Whatever. Lastly, and this is probably one of the most powerful things about Monday, I can tell you for every field on every requirement who made what change, when, what the old value is, and what the new value is. Full traceability. And there's an API for Monday, by the way. Okay? So whatever tracking system you put in place to satisfy that software engineering requirement, make sure it does this, and don't lose sight of why we're doing this. We're trying to work together to do something amazing, right? So these are the low-level details, and it's really easy to get your soul sucked out of your chest when you start thinking like this, right? Don't lose sight of the big picture. All right, so taking a step back and looking at, well, if that's like requirements and managing requirements, how do we respond and create designs and plans? That's all things Confluence, which in the same way that I'm a LabVIEW champion, I would like to think of myself also as a Confluence champion. I could talk about that for a good long while. I can hear Jason rolling his eyes with how much I talk about Confluence and DMC. All right, so part of us, DMC, putting designs together looks like declaring a Confluence page where the developer of a design starts writing some text, or maybe they put together a UML diagram, or maybe a UI and they embed it in the page. And then they say this very special text, this covers a requirement, and it links to a Monday item. So it's a hyperlink. Cool. Well, sure would be nice if I knew the specific ID of that requirement, right? I have written a wrapper in LabVIEW that sits on top of Confluence. And it is free, open source, MIT license. You can download it right here. On top of that API, I've written tooling that will scan through all of our design documents, find requirement covered, and then affix the specific ID to that text. So now I don't have to rely on a human being to make sure they typed in the number correctly, because humans. It's not that I don't trust people. No, I don't trust people, okay? I don't trust people to do this kind of activity, and we shouldn't. But so much more. This tooling, depending on whether or not it has been marked as safety critical, will also add additional information, like a banner at the top of the page for this design that says, hey, pay attention. You're working on a safety critical requirement. That means additional stuff. Here's a link to find out more for the developer when they actually implement the design. In addition, I can put things like iconography so that it catches your eye. This is a safety critical requirement, and I can programmatically add labels to pages. If we swap between, yeah, this is safety critical or not safety critical, I can programmatically update all of this, like remove the banner or add the banner back. You don't want to do that by hand, okay? Now, that gets us linkage from the design to the requirement, but remember, we need bidirectional linkage. So I need to be able to get from the requirement to the design. Using the same LabVIEW Atlassian or Confluence API, I wrote an additional application that is a part of DMC's internal tooling that will generate a chart, a table. It's like an audit. It says, here are all of the requirements, and then for every requirement, here are all of the designs that it takes to satisfy that requirement, because it could be an N-to-M relationship. One requirement might be satisfied by 5 designs. One design might satisfy 10 requirements. You don't want to do that bookkeeping by hand. I promise. Don't. Okay? You're going to get it wrong. So this tool that I wrote based on the Atlassian API, Confluence API, solves that problem. It generates this table programmatically, which means I can refresh this. It takes about 3 minutes to run instantly. Northrop wants to know, hey, did you guys cover requirements? Here you go. As a matter of fact, this entire table is one of our configuration managed items, and we can release versions of this over time. We're going to talk about configuration management in just a second. Why are we doing this? Because it's a requirement. NASA knows this is good practice, right? This is, which requirement is this? Oh, 52. I don't have my glasses on. Not only are we going to have to do bidirectional connection between design and requirements, there's lots of other bidirectional connections that we have to establish and update and maintain. Oh. Did I mention you need APIs for your tooling? All right, so not only do we need to link designs and requirements and create those things, there's lots of other things we have to create, like a software development plan. Certainly our software designs, great. The software interface and design description. Now I want to turn my attention to the developer architect side of the audience. You are on the hook to describe the interfaces of your software. But, like, what does that mean? Wall of text, don't bother reading it. Okay? This is straight from 7150.2. Now, one of the things, it's like NASA has done this right. The more I read through this requirement and the more I explore the supporting information, the more I'm like, the world needs to do it this way. And here's the reason why. Big wall of text. NASA has an entire workbook that describes what does that wall of text mean and even provides examples so that as an architect, you know what to create. It helps you align your team so that everybody knows what are the inputs and outputs of my software module, whatever that means. Okay? So again, my hat is off to NASA. Well done, you. After parsing all of that information, this is how DMC is creating its software interface design description. We're doing things like creating timing and event diagrams between asynchronous actors and elements of the system so that when the user initiates an action, that gets fed as a command to one software module that generates another command, that generates another command. So we can diagram all of that out. By the way, that can be programmatically generated. That's pretty cool. We also put together, of course, UML diagrams, high-level system overview with a software overlay. So you can imagine like a PC, and you have a couple modules on that, and your PXI chassis with a couple modules on that, and you draw lines between them and say, this is a TCP connection, and here are the kinds of commands that are getting sent, right? Software API documentation, and ... So all of that constitutes the software interface design description, which the architects and the developers are on the hook to produce. So I want to highlight one real quick. API documentation. Another tool that I wrote, and this is free and available to the world. This is where you download it, okay? This is built on top of that Confluence API. I can programmatically interrogate a LabVIEW project, LabVIEW library, LabVIEW classes, and generate a whole entire report that looks like this. I wish I could dive into this. We'll get to that in just a second. As an example of what it can generate, I want to draw your attention to just the private data of a class. I'm going to generate a table that says, here's the name of the private data, the description of the data, and the data type of the data. And the name of the data contains within it the structure. So I use this notation like a star is a reference, a period means the thing that's contained within, swirly brackets a cluster, square brackets is an array. To drive this point home, here's the private data of one class, I forget what it is. And so there is a cluster named user configuration. And inside of that, there's an array of paths. And inside of that array, there's another cluster called system cluster. And one of those elements is name. So that entire description gives you some sense of the structure of everything inside of your class, all programmatically generated, which means as that class changes, you can regenerate this report.
Is that based on JSON?
So yes and no. The square bracket and the curly bracket, that's definitely JSON. I don't think the period is. The star is just commonly accepted practice. The period might be. I could see that. But that's not, I didn't start from JSON. I didn't know enough about JSON at the time. Now I know JSON, so wish I followed that convention. Right. So this thing that I wrote, that's the robot up there, takes LabVIEW code and can print it out not only to Confluence pages, but also to GitHub, GitLab, Bitbucket at the same time. It's not like you have to run this thing once to do GitHub, another time to do. You can print to all four of these types of containers, if you will. And if you go to Confluence, you can also print PDFs and Word documents. This generates artifacts, which you're on the hook for in 7150.2. Okay? There's a whole entire presentation I gave while I was an employee at Cirrus Logic. Here's the URL to it, the link. It's a YouTube video about an hour and a half long that walks you through how do you use this system and what all can it do. What I just shared was just whetting your appetite. All right, now, so enough hand waving, enough PowerPoint magic. Let's actually dive into some code. How do you do what I've described? How do you programmatically do anything in LabVIEW? Well, there's a thing called VI scripting. And if you've not heard of VI scripting, that is LabVIEW code that can write LabVIEW code or programmatically interrogate that code. This is how you turn it on. So you go into Options, VI Server, turn on VI scripting. When you do, you get a whole new world, a whole new palette of functions and property nodes at your disposal. You'll know if you're in VI scripting land when you see these light blue colors for the VIs and such, okay? That's how you know you're doing more advanced stuff in LabVIEW, which is super powerful. It's also a little bit challenging. Well, what kind of stuff can you do, and why might you want to use that for 7150.2? Because maybe part of your old system as a developer, you tell your developers, go write a VI and link it to this one requirement. Sorry, I'm pointing over here. This is what the requirement is. All right, so how? You tell the developer, put a comment on your block diagram with a hashtag and the ID of the requirement that you're satisfying. Now you need to write code that programmatically examines all comments, grabs the VI name, and pairs it together with the requirement, right? Piece of cake. How do you do that? This is the actual LabVIEW code in this VI that interrogates this VI, reads this comment, and returns the text. What's going on up here? So I get a path to this VI, open a reference, call one of my new functions, and I say return to me all G objects on the block diagram, and return them to me as type text. Cool. I just so happen, I wish I could walk you guys through this, I just don't have the time. I know that the first element on this block diagram is this comment. Element 0 is actually the block diagram itself.
Oh, wow.
Right? That, and then, oh, okay. So I cast it to type text. I use my property node text to read the text out. Don't forget to close your references in the right order in which you open them. Right? You will.
You hate yourself if you don't.
You will not be pleased with yourself if you don't. Okay, great. How in the world are you supposed to learn about all of this? And I don't even want to call this the tip of the iceberg, right? This doesn't even do it justice. How are you supposed to learn how to do this VI scripting so you can write the tools necessary to interrogate the code to satisfy 7150.2 so we can go to space? Turns out in the LabVIEW wiki, there's an entire page dedicated to VI scripting. That's pretty cool. I'm curious, how many of you have heard of the LabVIEW wiki? Okay, 1, 2, 3, good. Ta-da, the LabVIEW wiki has tons of information inside of it. For folks who may not be aware of this, this is the community-owned, community-led, community-maintained, community knowledge base. Lots of information inside of here, well beyond just VI scripting. So well beyond that.
So anybody in the community can add to and.
You have to register with an account, but once you get an account, I'm pretty sure that you're good to go. I think that's right. Quentin Aldridge has a queue on the forums,
Yep.
has largely been behind this. In fact, he actually programmatically generates a lot of these pages.
Oh, wow.
So he'll use VI scripting to parse like a whole bunch of property nodes, get their information, and then generate this. So my hope is, as a community, we take ownership of this and have this be our knowledge store, knowledge repository, keep things up to date. All right? How in the world are you supposed to find out about the LabVIEW wiki, plus all of the other resources at your disposal? That's the nonprofit that I put together. This is your starting spot, right? This is like G Central. This is how you find out about not just all the resources like the DQMH consortium and the lava forum, Tom's hardware. This is just educational, which is certainly important. But how do we share code? Here are the 6 different things. How do you connect with others? Where do I find my LabVIEW user group and all that kind of great stuff? So G Central is meant to be your one-stop shop for how do you grow, how do you learn. gcentral.org. Check it out. And I'll say this: it is the LabVIEW community's first, but not only, nonprofit organization. The next one we're going to get to in just a second. Okay, all that was your software interface design description. Oh, hang on. Okay, so now we're going to pair together both project managers and developers, because we got to do this thing called configuration management. In a nutshell, what is configuration management? It's the idea that you take snapshots of important things so that there's agreed upon, we're going to refer to that version of that thing. Maybe that's a version of a statement of work. Maybe that's a version of your design documentation, 1.1, and everybody can make decisions off of that thing. Maybe it's a version of an executable that you're releasing out into the wild. Maybe it's the entire system, all of the hardware, the BOM, the software that's on it, whatever. Configuration management is a non-trivial task, and typically the outputs are something like a version 1.2.3.4.
I was just going to say, I would tie that to something in our group, basically document control, where they have all of our drawings and stuff in a database and manage it and all that stuff.
That's right.
That's what it is.
That's right. So it's all of the drawings, It's also all of like your UML diagrams, your UIs, all of your decisions behind your software. It's things like, what's the plan to develop the software, your software development plan to enable your team to perform functions a particular way. For example, before you check your code into Git, you have to get a senior engineer's sign-off. That's part of your software development plan. This is the codified, agreed upon marching orders for how we do, and it's version 1.1. Okay? At DMC, we ran into configuration management in lots of different ways. This very, very busy diagram is meant to represent the critical design phase, the critical design review. So we took as our inputs, before we made any code, we looked at the RTM, we generated Scrum items from that, so this is work items. From that, we make mock-ups and UI code. We show that to the client, in this case, Northrop Grumman. They edit their requirements in our work tracking system Monday, and we can see who edited what and when and why, from which we generate Scrum items, and we update design. And so we're doing this over and over again. We're updating our acceptance test plan, which remember is linked to the RTM. I got through that. And then we've got that requirements coverage table, that side-by-side comparison. Here's the requirement, here are all the designs that satisfy the requirement, right? So we're doing that over and over again. And at some point in time, ship it, right? So you got to stop and you take a snapshot. And we generate exports of lots of different documentation. And then we present them to the client. We say, what do you think? And they're like, yeah, cool. We're like, cool. We can now put together timelines and budgets, updates to the RTM, coverage table. So this becomes plan of record, realizing, this is, everybody at DMC knows I say this, the plan is the plan until the plan changes. But you can at least say we're at version 1.1, 1.2 is likely coming, but here's the plan until you hear otherwise. This was designed to generate a plan. Oh gosh, how do you do that? If all of our designs are in Confluence, well, there are literally thousands of pages. Do you stamp each page with its own separate version? And, oh God, what a nightmare. So based on the Confluence API, I wrote this application called Confluence Configuration Item Release Tool, or CIRT. Just so happens to also be like certified, or some certificate. See what I did there? Marketing. Last 2 years at NI. Marketing, right there. What's in a name? Everything. All right, so now this is actually a video. I'm going to try and walk through it, and we'll see how this goes. All right, so CIRT will tell you the specific configuration item and its specific title. Great. Either one. Cool. Who owns it? What version you are currently at, and what's the next version due for release? This is almost like a build spec inside of LabVIEW. I want to know what are all the versions we've released to the client. And you know what? I don't care where they are. I just need to get my hands on them. Like, are they in some SharePoint directory somewhere, which you have to remember what the SharePoint directory structure is? What a nightmare. Yeah, I don't want to remember any of that. All I want to do is, so that was why we shipped it, who shipped it, and on which date. And I just want to double click on it and have it open to wherever it's stored. That specific version. Great. I also want to be able to go to the source. You might not have seen Confluence before. This is Confluence. CIRT, upon release, will programmatically update what revision we're at and the date of release, because APIs are important for the tools that you choose. You don't want to do this by hand. I promise. You'll screw up your configuration management. It's a nightmare. So I built CIRT to alleviate that task. Oh, but wait, there's more. Wait for it. Maybe you want to make a change to your content. Maybe this is a Word document. Maybe you're updating UML design, whatever. You're doing some change. And you need to be able to say, here's the reason why I'm making that change. This is all built into Confluence at this stage. So you're adding comments. And remember, there's hundreds, maybe thousands of pages. So you say, here's some change. I need a way to get all of the pages that constitute a configuration managed item, aggregate all of those notes from all the developers, and show them in one summary table. Wait for it. There it is. So there's the note that I made on this date. It was me on this page. I can do that for every change. And I can update that list, I don't know, within a minute, constantly. Oh, but wait, there's more. Because that's version 2. What changed? Like, what is version 2? Built into Confluence, wait for it. Yeah. That's me saying, stuff. I select 2. Confluence has built-in diffing capability. So from version 1 to version 2, this line was added. I can see that for every page, for every version that constitutes my configuration managed item. I'll take that. Okay, that's how the video actually worked. Hooray, beer. All right, that's CIRT. Right? You are here. There's a lot. You are here. Remember the big picture. We're doing this to put people into space. It's worth it. It's hard. You're here. It's fine. Keep going. If you find that you're beginning to lose your soul, and you're like, God, this is like pushing a boulder uphill. This is Alan C. Smith. Have you guys heard of the actor framework? Yeah,
I use it religiously.
Hey, arguably the world's best actor framework developer. In fact, he's doing a lot of really cool behind-the-scenes stuff. He and I get the chance to hang out from time to time. This is us on a Texas barbecue safari.
I took his class, and it's phenomenal.
Right? Amazing. Major props out to Alan. If you haven't gotten the chance to meet him, you're missing out. He coined a phrase which I love. We don't serve systems. Systems have to serve us. So all of these things I've been talking about, how do they serve us? Like, really, like for real. A bit of a wall of text. Okay, setting up these systems and getting involved early pays major dividends. Just take my word for it. All throughout the project, but especially at the end. It helps us ensure quality because we all want to do a good job, right? So this serves us by helping answer the question, are we doing a good job? Builds confidence in your stakeholders. I always want Northrop and whoever I work with to go, yeah, that Chris guy, I know he's just going to be able to do whatever I ask him, and I'm going to like what comes out. It enables developers to code with confidence. There's nothing scarier than you changing an element of your code and asking, oh God, I hope I didn't break something elsewhere. Unit testing, which is mandated, helps out there. And then did I remember to, a long laundry list. So these systems serve developers by alleviating anxiety. Right? Okay. Helps project managers be reliable and accountable. That's what a project manager is. Helps objectively answer how are things going, and so much more. So these systems that we're putting in place, they are serving us. We're not just checking a box somewhere. Okay, let's talk about production, because we haven't even started producing code yet. Remember I said everything has to be linked together? Well, our app dev team worked with the test and measurement team at DMC to put together a report like this for every build that we make. I can tell you which requirement links to which design, what code satisfies that design, which tests test that code, and what the last test result was on that test for automated tests. I can also get a summary. This is for every build, okay? Programmatically generated. That's V&V. Now we get into software quality assurance activities. There's lots that I could say about this. My good friend Kevin Shirey, who's on the call, fellow DMCer, fellow CLA, fellow LabVIEW champion, gave a presentation about how we did LabVIEW quality assurance at GDevCon. Again, how many of you have heard of GDevCon? Got a handful of folks? If you've never heard of it, this is a link to it. This is the LabVIEW community's second nonprofit organization. Its whole entire purpose is to provide a conference for G developers, more or less as a replacement for what NI Week used to be and the CLA conference. So now it's completely owned by the community, maintained by the community, lock, stock, and barrel. It is a fantastic event. So Kevin gave a presentation on these 3 tools, very quickly. The Requirements and Safety Manager. This is a tool that we run on code, programmatically inspects code, and stitches together. That code satisfies that requirements, generates a text document that's ingested by that table that I showed you earlier. One of our requirements is thou shalt not ship dead code, What that means is, in the built, configuration managed, executable, every bit of code in there must be able to be executed according to some intent. In other words, there shouldn't be an algorithm that can never execute. That's dead code. This tool that we wrote internally makes that a possibility. This tool, which is public and free and open source, is VI Analyzer on steroids. It can run VI Analyzer, but it does so much more. The real value proposition of this tool that Kevin wrote, this is a link to it. Remember how I said it was hard for quality assurance people to take a look at code without getting the full development environment installed? This solves that problem by generating a report of all of the quality metrics that your organization cares about in a PDF or in a Word document, so that the person who's reviewing the quality can just look at the report and then give feedback on that. They don't have to have the IDE installed. Sounds like a great idea. Now, that's just the tip of the iceberg of what this thing can do. It can do a whole bunch more, but that's the biggest one. Now, this is a reminder to both me and to everybody else who's watching. This is a lot of stuff that we've covered, right? And it's not like I've gone through every requirement and said, this is how you solve this problem with the National Instruments toolchain, because I could spend 5 presentations on any one of these requirements. Like, there's no way that we're getting through all of this, and that's okay. My goal, remember, was to inspire you in what your job is, to put some tools in your tool chest, like those APIs and a couple of other tools that we've got, so equip. Also put some resources like G-Central and the LabVIEW wiki at your disposal, and to paint a path of what adhering to 7150.2 might look like. Why are we doing all that again? God, this is so much. Okay, because I believe that as scientists and engineers, we can impact this world almost more than anybody else can throughout all of human history. And the only thing better than a scientist or engineer impacting the world is when we do it together. 7150.2 is a means to that end. How can we help? So here's an offer I make to anybody watching, to you all in the room. If you want to whip out your phone, take a picture of that. DMC can come alongside you in your organization and consult. Like, say, here's where some gaps are in you meeting 7150.2. Maybe here's a plan that we can put together to get you there. DMC can help implement those tools like CIRT for your organization. Sounds great. Or you guys just don't worry about it, right? Don't bother. We've gained the expertise. We have the in-house tooling. We can do the entire project like we're doing for NASA through Northrop Grumman for the BOLE project. So if you want to take a picture of this, that'll take you to a form that you fill out that goes directly to me. I will reach out to you, contact you, and we'll set up like an hour consultation, 2-hour consultation, whatever, to see how can DMC help. Okay? This is also the printout that Jason gave. For those of you who are watching remotely, screenshot this, okay? Screenshot it. And I have 2 minutes to spare. How about that? Questions?
It seems like anybody wanting to do these kind of things that you're showing here, it's going to be for a project going into space or a very big project, not some smaller, uncontrolled project that might.
That is correct. So 7150.2, well, there's different classifications of software, and it depends. Not all of these requirements will always apply to every application. Your software and its application get classified as A, B, C, D, E, or F, and then, depending on your classification, it'll determine which of those requirements you have to obey. There's a second dimension as well, which is, are you safety critical or not safety critical?
Oh, yeah.
Right? Yeah.
Oh, I've dealt with safety critical.
I have too.
Yeah, it's easy, right?
No.
No, it's not easy. It's a real pain. So there's these 2 vectors that you have to consider when thinking through 7150.2 and all of the references to other documents from 7150.2. What is your classification? NASA also has an entire handbook that says, how do you figure out what your classification is? Once you figure that out, then you figure out there's a matrix at the end of 7150.2 that says if you're this classification, here are the different requirements that you have to obey. Also, Travis, Travis released a PowerPoint from, October 2023, where he had a link to a video from somebody at NASA. It's a 20-minute video that says, this is how you do 7150.2. And she actually highlights this idea of classification and then how much of 7150.2 you have to obey. Make sense?
Yes, I was just gonna say, I have to use 7150s. I've been having to use them for the last couple of years with my LabVIEW projects, even if it wasn't safety critical.
Oh,
That's the measurement.
and it was not safety critical? Lucky you.
They're wanting to have us start doing it just so that we can have.
Oh, man. Oh, man. So there's some implications to that. And that's why I put at the banner at the top of all of our designs, see safety critical considerations for the. So as an example, we say to the developers, you have to indicate on your block diagram which parts of these code is safety critical. So you put a decoration, a red decoration. For a VI that contains any of that, there has to be a red border around it, things like that.
Okay.
So lots of different.
I wasn't aware of that, so I need to.
And also to be fair, 7150.2 was flowed down to DMC through Northrop Grumman. So Northrop Grumman took 7150.2, did their interpretation of it, added, and even, added what they would like to see in response to 7150.2, passed that onto DMC. So there's some tailoring that DMC went through because Northrop Grumman tailored a little bit of 7150.2, which is fine. Like, you can do that. I talk way too much. Was this useful, helpful?
Good, absolutely.
Okay,
Yeah,
great.
fantastic. Were there questions online? We should check the chat
Yeah.
real quick. I'm going to pull up the Teams chat just for a moment, see if there are any questions.
Oh,
Anybody verbally want to toss a question out there? Looks like
Oh,
there's, go ahead, Kevin. Maybe that wasn't Kevin. Whoever was speaking there.
Oh, I had my hand up. That was basically what I was about to say. But if somebody else was about to speak, I didn't hear anything.
No, go ahead. Go for it.
Okay, great. Let's see. A great presentation, definitely. So just a great, as far as trying to do what is considered to be a water hose a style, it definitely comes across very straightforward. Let's see, but yeah, at least for me, I know just as one other guy had mentioned, the software that is in our lab is pretty much straightforward, the Class D safety critical. So again, it was something that was thrusted upon me from years back. So, but at least to the presentation, the Monday.com, I had I guess maybe one question mainly, and it seems to be enterprise